Okay, so the last 2 years, they've been super unpredictable, all the way from productivity to supply chain management to resources. The environment's been so variable. So how do we continue to improve productivity while lowering costs, but yet still have time to innovate?
We at AWS have a solution using computer vision, where we do the heavy lifting and you do the things that matter to you the most. My name is Gaurav Kaila and lead the prototyping team for UK and Ireland, where we help customers just like you prototype use cases using emerging technology.
And I'm Pratyusha Cherku. I'm a Principal Product Manager, AI ML Computer Vision at AWS. I focus on building low-code, no-code solutions for AWS customers. And today we'll talk about Amazon Looker for Vision, which is a low-code, no-code solution that helps customers automate their quality inspection. Okay, let's get started. I'll very quickly run through the agenda. We'll talk about quality management, why quality management is important, how can you improve quality management using computer vision, how can Amazon Looker for Vision help you in improving your quality management using computer vision. Then my colleague Gaurav will walk you through what does quality control at scale mean, and then we'll look at a case study. All right, let's dive in. Now, before we talk about quality management, I'm sure a lot of you have probably heard about Industry 4.0 or Industrial Internet of Things. Now, what does this mean? This means customers across asset-heavy industries like discrete manufacturing, whether it's consumer packaged goods, healthcare, life sciences, automation, or transportation, logistics, agriculture, utilities, energy, and mining, they're investing in artificial intelligence and machine learning capabilities, cloud computing, and advanced analytics to digitally transform their companies. Through this, they will improve their productivity, they can reduce costs, and have consistent quality. But as with any change comes a set of challenges, or as we at AWS call opportunities. So what do these customers across all of these industrial workloads need? They want the ability to innovate, continue to innovate products, continue to optimize their product design. They want to be able to utilize their assets efficiently, right? So asset optimization. They want to be able to improve their quality, reduce their costs, and consistently raise the bar on quality. And they want to do this while keeping their workers safe, having a robust supply chain management, and building smart products, either to augment their existing workflows or to be able to create new revenue streams. Now, AWS can help you across all of these different workloads. AWS has the most extensive and comprehensive set of cloud computing capabilities, a robust partner network that can help you build solutions across that can help you meet these needs, and you can leverage the highest security standards that you've come to expect from AWS. All right, and today, like I said, we'll focus on quality management. And as you can see from this slide, computer vision applies across all of these workloads. So what does quality management mean? Using automated visual quality inspection, either in line or at the end of the line, can help you reduce false rejects, reduce false accepts, and reduce scrap rates. You can also improve process control. You can integrate the inference results from your machine learning models, either, excuse me, in your PLC systems, your SCADA systems, or any guidance system to automate how you want to handle when a defect is detected. For example, every time a defective product is detected, you can take that product and put it in a different bin. You can also do root cause analysis, right? Integrate these inference results further upfront in your computer network, or augment this with machine data to identify patterns, look at when defects were created, how they were created, or improve data collection. There's even further advanced use cases where you can use computer vision for in-field inspection. You can use it for supply chain management or even product design. All right, now let's look at a few metrics. Aberdeen Group has said that the true quality-related costs could be as high as 20% of the sales revenue for many organizations. And Warranty Week estimated that in 2018, about 26 billion is what US-based manufacturers had to pay in total claims. Let's look at what are the different categories that contribute to this cost of quality. According to Gartner, as you can see, these are the top 5 internal and external failure metrics. 83% of that 20% we just saw could be defect rework, there's scrap, customer returns, complaints in warranty, and then there's about corrective action process, which contributes to about 57%. Okay, so how have customers been reducing this cost of quality? What have they been doing? Manual inspection is the most common one, where you have resources either in line or at the end of the line where they're manually inspecting your product as it's making its way through the production process. Now, this is definitely agile, it's flexible, but how do you make this work at scale? Is it repeatable? Can you get the same consistency? This varies because it's based on who the human inspector is. So the quality inspection process, you won't have the same consistency. Your throughput could be limited depending on who the operator is, how many operators you have. It's subjective, as we just talked about, right? And more importantly, the feedback loop. The feedback loop could be slower, again, depending on who the operator is. The feedback could make its way back to you, or it may not. Okay, so can we do better? And yes, customers have done better. They've used machine vision. What is machine vision? Machine vision uses image analysis for automation. Now, with machine vision, again, you can use this inline or end of line, but it's definitely faster than manual inspection. Yes, it's repeatable. It lowers the cost of inspection, and yeah, your feedback loop is faster. But on the flip side, if you've looked at machine vision systems, they come with a particular camera, a particular operating system, and there isn't a whole lot of flexibility to mix and match. You're bought into that entire system. So this results in very high upfront costs. As we talked about, it could be inflexible, right? You can't necessarily mix and match different hardware components to meet your needs. And if there are changes in your environment, if you want to quickly iterate on your models to adapt to changing work environments, to adapt to changing product design, you may not be able to do that as quickly as you would like to with machine vision. And with machine vision, the scope could be limited. So based on this feedback and listening to our customers and what they've told us about some of the challenges they've had with, with machine vision and manual inspection, AWS launched Amazon Lookout for Vision. Amazon Lookout for Vision helps you spot defects using computer vision. So what is Amazon Lookout for Vision? Amazon Lookout for Vision is a machine learning service that uses computer vision to spot defects in your manufacturing products at scale. As we talked about earlier, with computer vision, you can reduce false accepts, you can reduce false rejects, you can reduce your scrap rates, you can improve process control by integrating it with different systems, automate how you want to handle defective processes. You can improve your root cause analysis, right? You improve your data collection processes. And overall, you've got speed, consistency, accuracy with real-time visual inspection using machine learning. Okay, now let's look at some of the features of Amazon Lookout for Vision. As we talked about, computer vision, every single customer, right, but every single industrial customer, they have different quality inspection needs. Everybody has different KPIs. So how do you build models that can cater to different customers' needs? Amazon Lookout for Vision helps you build your own custom model that caters to your specific needs with as few as 30 images. You upload 30 images, and Amazon Lookout for Vision does the heavy lifting for you. We'll generate the model for you. And the best part is no machine learning expertise is required. You can use these models on any hardware device of your choice. You can use it on the cloud. You can use it on the edge. If you want to use lower resolution cameras, you have the flexibility to do so. More importantly, you can iterate on your model as often as you like till you're comfortable with the output that is produced by the model, till you're comfortable with the results. So all in all, with Amazon Lookafter Vision, you've got improved defect detection, you've got speed, you've got consistency, you've got accuracy compared to your manual inspection. You've lowered the cost of quality control inspection compared to machine vision systems with greater flexibility. All right, so how does this actually work? How can if I want to use Amazon Lookafter Vision, how do I get started? Let's look at the customer journey. As you can see in this process, you first collect images, right? The images that you think are substantial and that make sense, and you want to feed them into Lookafter Vision to train your model. Again, you can get started with as few as 30 images. You upload those images to Lookafter Vision. Lookafter Vision, you label these images, and you tell us what defects you want the model to look for. Amazon Lookafter Vision generates the model for you. Then you have the ability to evaluate this model, look at the metrics, see if this is meeting the KPIs that you care about. You can provide feedback, and this feedback can be used to iterate on the model till you're satisfied with these results. You can also look at the dashboards to monitor the defects and what the improvement in the process is. Finally, once you're happy and you're satisfied with the model, you can then use this model on the edge, on the device of your choice. And now process engineers, plant managers, operators, they can, they can use these models to automate their inspection process. And the best part is they can provide feedback in real time. And this feedback is used as input to iterate on your model, improve the model to meet the conditions that you desire. So and that is the continuous improvement loop that you see in the slide. So when it comes to model training and ML ops, Lookafter Vision has drastically simplified that process for you. Great, so now we've looked at the customer journey. How do I, as a customer, use Lookafter Vision at scale or use computer vision at scale? Let's look at some of the challenges. Right, when a customer is thinking about implementing computer vision at scale, what's the first problem? They want to understand how many images do I need? Do I have enough data to create my models? How do I train my model? What is the time required to train my model? Do I have the right skill set? How can I validate my model? And how do I test it to make sure that the model meets the KPIs that I need? As we talked about with Lookafter Vision, you can create models with as few as 30 images. You don't have to worry about having the right skill set because we do the heavy lifting for you, and you don't need any ML expertise. Now, the second challenge, if you will, customers want to run these models at the edge. They want to be able to run these models on their existing infrastructure and leverage the same computing and security requirements. With Lookafter Vision, you can run these custom models on any hardware device of your choice. And you can also use lower resolution cameras for your data collection needs. Now, the third challenge is maintain. How do I make sure that I have very limited support required to improve these models at the plant, adapt to changes whenever there's a change in the process, when there's a change in the environment? Again, as we talked about with Lookafter Vision, you can provide real-time feedback for continuous improvement, iterate on your models as often as you like till you're satisfied with them. All right, so we talked about what is Lookafter Vision, how do you use it, how can you implement it at scale. Now let's look at some of the most common use cases. The most common use cases that we've seen with Lookafter Vision are surface defects, like you see here, scratches, dents on your printed circuit board, automotive door, or if there is an improper solder, the shape, it's not the shape that you expect. You can look at all of those defects. You want to identify missing components, so if there is a particular component on your product that's missing, or you want to identify the severity, how big is this defect, right? What is the percentage of this defect across my entire image? Or you want to identify porosity, you can use Amazon Lookup for Vision. Or you want to uncover process issues where you're seeing consistency issues like the steel coil, you can use Amazon Lookup for Vision. So now let's look at a few customers who've been able to use Amazon Lookup for Vision and optimize their quality inspection process. Invista is one of our early adopters. And Invista manufactures chemicals, polymers, fibers, and many other products. Now, Invista wanted to increase their yield and their overall equipment effectiveness across high-value, high-volume products by detecting anomalies early in the process. So Invista used Amazon Lookup for Vision, and they built a machine learning computer vision model that could detect anomalous conditions either to augment human-in-the-loop workflows or to fully automate root cause analysis and predictive maintenance using artificial intelligence and machine learning. The goal was to minimize loss of production and to optimize asset operation. With Lookup for Vision, Invista was able to reduce their cycle time from 60 seconds to 5 seconds. So from a whole minute to 5 seconds. Let's look at some more examples. Tyson. Tyson Foods is one of the largest food producers in the world. Operational excellence and worker safety is a key priority for Tyson. And so predictive maintenance is an essential asset for them to achieve overall equipment effectiveness. Now, as you can see in this image, Tyson wanted to detect if these product carriers were didn't have the right quality, right? Either the hinges were loose or the product that they're carrying has fallen off the carriers. So they could, A, prevent, minimize these issues like product loss issues, and also identify asset management issues or predictive maintenance issues earlier in the process so they can improve safety for their workers. With this, today, before Lookup for Vision, they were doing this process manually, but operators were inspecting close to 8,000 pins very manually, and this was a complex process, and there was a lack of consistency. With Lookup for Vision, they were able to significantly reduce the cycle time and get consistent results across 8,000 pins. All right, one more customer, Baxter International. Baxter International is a global medical products company, and they manufacture a variety of healthcare products all the way from syringes to IV bags. For Baxter International, they wanted to use computer vision, and particularly Amazon Lookup for Vision, to automate inspection tasks that were very complex, were difficult to do either through manual inspection or machine vision. So they used Lookup for Vision's cloud and edge capabilities, and they were able to scale in a rapid and agile manner. They were able to drive efficiencies across the manufacturing floor, and they were able to enhance their operators' productivity and experience. Okay, so now we've looked at what is Lookup for Vision, how do you use it, how do I implement it, how does it work at scale, what are some of the more common use cases, and how have a few customers and examples of customers that have been able to use Lookup for Vision and derive value from computer vision. Now, my colleague Gaurav will walk you through what does quality control at scale mean and a case study.
Thank you, Usha. So, what we have learned till now is how computer vision, especially Lookout for Vision, helps customers alleviate the problem of quality inspection. In the next few slides, I'm going to walk you through a customer case study where we helped a customer build an end-to-end solution to help them alleviate the problem of quality inspection. As someone who sits with our customers every day, me and my team realized a pattern with a lot of our manufacturing customers. They had very similar problems. I've put down some of these problems on the slide set. First, they spend very little on their IT. Some spend as little as 2% on their IT. A lot of them are very traditional, so change is very, very slow. A lot of them are talking about Industry Transformation 4.0, but very few of them are actually implementing it. A lot of these customers have siloed OT and IT, so operations and IT teams don't really talk to each other. So there's a misalignment in their vision. Sitting down with one of these customers, which is the world's third largest bottle manufacturing company, they told us that they have a very similar problem, but came to us with two requirements. First is provide us a solution, not a service, for elevating the problem of quality inspection. And second is, can we provide to them a centralized data dashboard where they can look and identify the problems and take actions in near real time. We took up this challenge and we distilled this down to 3 use cases. The first use case is the problem of quality inspection. As Usha mentioned, this is a problem that a lot of our customers face. And the current state of this is a lot of customers are employing manual human intervention in order to identify products that are defective. As you can imagine, this takes a lot of money, this takes a lot of time, and it's very error prone. Our proposed state for this is to use services such as Lookout for Vision to identify these defects and augment the process of that the humans are doing. The second problem is, how do we relate the defect to the root cause? It's good to know the defect, but it's better to know what caused that defect. The current state on how customers are identifying this is again very manual. It takes a lot of time, takes a lot of money, and again, it's very error prone. Our proposed solution is to capture data from the factory floor itself, from the manufacturing line itself, such as temperature and running speed of the manufacturing line, and relay that back to what defect there is, and identifying which part of the manufacturing line might be the culprit. The third use case is, how do we scale this out? So the use case that I'm discussing here is quality control at scale. So how do we scale this out? We don't want to do this for one manufacturing line. We want to do this for many manufacturing lines across different factories across the world. Currently, a lot of our customers that have manufacturing lines across the world are siloed. Factories don't really talk to each other. So a problem in one particular factory is not really relayed to other factories around the world. What we did is we built a dashboard that connects data feeds from multiple different factories, so factory operation managers can have a look at the centralized dashboard and identify problems in one factory and relay that information to other factories. What we built for this particular customer is a demonstrator, for which I'm going to show you a video. In this video, you can see that we have a conveyor belt. This simulates a manufacturing line. There is a product, in this case the orange bottle. It passes through the conveyor belt underneath what we call a light box. This light box houses an NVIDIA Jetson device, which is running a machine learning trained model from Lookout for Vision. This Lookout for Vision model is trying to identify if there is a defect on the bottle or not. We are targeting 2 primary defects. Defects on the bottle body, that is scratches, and if there is a missing bottle cap or not, so if there is a cap on the bottle or not. As you can see, the first 2 bottles that pass through the system, there are no defects, and the robotic arm picks it up and places it on the end at the end of the conveyor belt. Whereas for the third product that is coming in, you can clearly see that there is no bottle cap. Hence, the robotic arm knows that there is a defect and picks up the bottle and places it on the side. All of this is happening on the edge itself. That is, the Lookout for Vision is running its inference on the edge, passing this data to the robotic arm that is then able to understand where to keep the bottle. All of this is very good, but how do we take this data now and pass it to the cloud? For that, we built a dashboard. We took the data that we are collecting from the field itself, from the manufacturing lines, such as the inference data, the temperature data, the running speed of the manufacturing line, put it through the cloud using IoT Core, ingested this into TimeStream, and created different metrics. So one of the metrics that Usha spoke about is OEE. OEE is a standard metric that manufacturing customers use. Our customer wanted us to visualize this metric for a lot of their manufacturing lines, and we did exactly that. On the slide, you can see that we have a dashboard that shows a map. In the map, you can see different factories all across the world, and they're color-coded by how well they're performing. Green means good, yellow means not so good. So you can see Tokyo and Washington are doing quite well, whereas Frankfurt, not so good. We also have a bar chart that visualizes the OEE, the cumulative OEE across all the different factories. So you can see over time if the OEE is changing too much or if the OEE is fine. The factory operations manager can have a look at this dashboard and can drill down to a particular factory that is maybe not doing so well, so maybe Frankfurt. Within the factory dashboard view, you can see there are multiple manufacturing lines. Some manufacturing lines are running, whereas some are not running. So line 1 to 5 is, line 1 to 4 is running, line 5 and 6 are not running. We also have the OEE and the number of products that have been manufactured by each line. Now, the factory operations manager can deep dive into one particular line that is not running, say line number 6, and identify what is the problem. In this dashboard, this is the line view, where you're able to identify that if there is a problem with this line or not. In this case, you can see that we are visualizing the image of a bottle. On that, we're overlaying a red bounding box that indicates that there is some problem with the bottle body. In our case, it's a defect, it's a scratch on the bottle body. Capturing this information and the other information that we've captured from the manufacturing line, such as the temperature and the manufacturing running line speed, we're able to relay that to a particular part of the manufacturing line, which is the cold intrusion spec, to say that this might be a problem, this might be the root cause of the problem. Now, the operations manager is able to take near real-time actions in order to fix that problem and also relay that information back to other manufacturing lines across the world. We also have sort of a time series chart here that tells you how well the products are doing and what are the scratches or what are the defects that are being identified over time. So all in all, we were able to build a solution that addressed the 3 use cases for our particular customer and able to combine multiple different services to come to this solution.
Okay, so over the course of this presentation, hopefully we were able to show you how you can use Amazon Looker for Vision to improve your quality inspection process. And when you combine it with other AWS services, you can build an end-to-end solution that is customized for your specific needs. Thank you.